Chapter 13. Introduction to Graph. Graph is a drawing depicting the relationship between two or more variables, set of numbers or quantities with reference to two axes. It is a method of representing a point in a plane. In other words, we say that graph is a method of locating positions in a plane mathematically. While studying number lines, we have learned how to position a particular number on number line. Let us recall our memories. We had drawn a line and marked one point as the origin, numbered as 0. Representation of points has to start with respect to this point. Any positive number lies on the right of origin, 0, and all negative numbers lie on the left of the origin, 0. Positive, 0, 1, 2, 3, 4, 5, 6, negative, -1, -2, -3, -4, -5, -6, -7. Positive numbers are to the right of 0. Negative numbers are to the left of 0. Now, if we want to mark a point +5, we have to go towards right of 0. Similarly, if we want to mark -6, we have to towards left of 0. Example, locate the following points on a number line. A. Point X +7. B. Point Y -4. C. Point Z 0. Solution. Draw number line as shown below. Mark the origin first as 0. A. Point X is +7, so we have to go to right of 0. Mark the point at +7. B. Point Y is -4, so we have to go to left of 0. Mark the point at -4. C. 0 is already marked. Name it as Z. The Cartesian system. The system of locating a point in a plane by vertical and horizontal measurements is called the Cartesian system. Example, there are 12 cricketers arranged in columns and rows as per the following pattern. All the cricketers are numbered as 1, 2, 3, up to 12. The position of each cricketer is as follows. Column 1, Column 2, Column 3, Row 1, 1, 5, 9, Row 2, 2, 6, 10, Row 3, 3, 7, 11, Row 4, 4, 8, 12. Let us take number 3. The number 3 is placed at third row and first column. We can represent the position of number 3 as 3, 1. Similarly, number 6 is placed at second row and second column. We can represent the position of 6 as 2, 2. The number 12 is placed at fourth row and third column. So, the number 12 can be represented as 4, 3. We say 3, 1, 2, 2, 4, 3 as the coordinates. The x-coordinate is called the abscissa and y-coordinate is called the ordinate. We are familiar with graph paper. There is one horizontal line, x0x, which is called the x-axis, and one vertical line, y0y, which is called the y-axis. They meet at point O, which is called origin. Along y-axis, all positive numbers are above the origin. Inversely, all negative numbers on the x-axis are on the left of origin. And all negative numbers on the y-axis are below the origin. The coordinate axes divide the plane in 4 regions. Each region is called quadrant. The quadrants 1, 2, 3, 4 are marked in anti-clockwise direction. Any point in the plane is represented by horizontal distance and vertical distance with respect to the origin, that is, the point 0. The two distances are written as pair, P, Q, where P is the horizontal distance comes first and Q is the vertical distance comes next as per convention. The pair, P, Q, is called ordered pair. Now, for example, if we have to locate the points 2, 3, minus 3, 1, minus 1.5, minus 2.5. How we go about it? What will be the quadrant for each location? To locate point 2, 3, we have to move 2 units in positive direction along the x-axis and 3 units from that point in upward direction. The required point is 2, 3. To locate minus 3, 1, we have to move 3 units along the x-axis towards left of 0 and then from that point move 1 unit towards positive direction, that is, vertically upwards. The required point is Q minus 3, 1. To locate minus 1.5, minus 2.5, we have to move 1.5 units along the x-axis towards negative direction, means left of 0, and from that point 2.5 units towards negative direction, means downwards. The required point is minus 1.5, minus 2.5. Now, we have to find out in what quadrants these points lie. Point 2, 3 lie in quadrant 1. Point minus 3, 1 lie in quadrant 2. Point minus 1.5, minus 2.5 lie in quadrant 3. We observe that quadrants have some relation with the signs of the coordinates. Quadrant number. Signs of coordinates. Quadrant 1 plus, plus. Quadrant 2 minus, plus. Quadrant 3 minus, minus. Quadrant 4 plus, minus. Example, determine the quadrant. A. Point X, 8, 4. B. Point Y, minus 7, minus 5. C. Point Z, 6, minus 3. D. Point O, minus 9, 2. Solution. A. When signs of coordinate are plus, plus, it falls in quadrant 1. So, point X will lie in the quadrant 1. B. When the signs of coordinates are minus, minus, it lies in quadrant 3. So Y lies in the quadrant 3. C. When the signs of coordinates are plus, minus, it lies in quadrant 4. So Z lies in quadrant 4. D. When the signs of coordinates are minus, plus, it lies in quadrant 2. So O lies in the quadrant 2. Special coordinates. The origin point O where x-axis and y-axis meets has the coordinate 0, 0. It is not moving to any direction. Any point lies on the x-axis means it has some value on x-axis, may be positive or negative, but its y component is 0. Example 1. Pointer has coordinate 6, 0. Point B has coordinate minus 2, 0. Any point lies on the y-axis means it has some value on y-axis, may be positive or negative, but its x component is 0. Point C has coordinate 0, 4. Point D has coordinate 0, minus 3. Line graph. We know how to plot points if the ordered pair is given. In the ordered pair there are two variables x and y. If the points plotted in Cartesian plane follow a pattern, then we can say that values of x and y may be related in some manner. This means x and y are connected by certain rule. If the plotted points form a straight line, we get a graph called linear graph. Now, let us consider a simple linear equation y is equal to 2x. Here, x is an independent variable, means the values of x can change. The value of y is dependent on the values of x. Y is called the dependent variable. Take the equation y is equal to 2x. The values of x and y could be x 0, 3, 4, 5, 6, y 0, 6, 8, 10, 12. Now, let us plot the above points 0, 0, 3, 6, 4, 8, 5, 10, and 6, 12. When we join all the points, we get a linear graph passing through the origin. With the help of this graph, we can find the values of x and y if one of them is known to us. Now, let us consider x is equal to 1. We draw a line parallel to y-axis. The line intersects the graph at some point. That particular point is the value of y. Here, x is equal to 1, y is equal to 2, or we can say y is equal to 4. Find the value of x. Locate the point y is equal to 4. Draw a line parallel to x-axis. The line intersects the graph at a point where the value of x is 2. Similarly, any value of x and y can be obtained if the value of one variable is known to us by extending the graph both in positive and negative directions.